Okay. We just discussed one example in case of probability from Venn diagram, and moving onwards from here, two examples of exercise. In a class of 25 students, some study French and some study German, some study both. This complete is French, this complete is German, both are 7 and none are 3. This information is illustrated in the following Venn diagram. Universal is given, F is given, G is given, French and German. If a student is chosen randomly from class, find the probability that they study French. So I can see in French there are 9 plus 7, 16 students out of total 25. So 16 by 25 for French. Second part says F intersection G. So the intersection part is only this, that is 7 out of 25. Third says probability F complement intersection G complement. So when I'm talking about F complement, these are the two areas. And when we talk about G complement, other than G, these are the two. So what's common in them, what the intersection part common in this blue and red circle is only 3. So these are 3 out of 25. And then the last one is F complement. F complement is 6 and 3. Intersection with G, let's say G is these two. So the overlapping part is only 6 out of 25. Let us give a real world interpretation of A3. What was A3? That was this. So a real world interpretation may be like one of your class fellows who's not taking either subject. And A4 is 6. So any student who's taking the other subject, like let's say history and geography, so they're taking geography but not history. So let me just confirm the answer. 16, 7, 3 and 6. 16, 7, 3 and 6. Try question number 2. Share your answers as you solve them. Still doing? Is the first part done?
It's for the people who like carrots is 14 over 30.
Like carrot.
Yes, sir.
This is carrot.
So, but sir, who like carrots? So is it going to be the L, 10 and 4?
Oh, sorry. I looked at C for carrot.
Yes, yes, sir.
Those who eat carrots, those who like, yeah, you're right.
So 14
14
over
by 30.
30.
And we definitely need to simplify it as well in exam.
Oh, yes,
7
sir.
by 15. Okay. Does not
But
like carrot, but does eat them.
this is a 7 by 30. 7 by 30.
7 by 30. Does not like carrot and refuse to eat them.
3 by 25.
Where are
16.
you getting this 3 from?
So I think
Very
10
from
does not like carrot.
where?
I mean, 4,
C says does not like carrot.
5,
So
9, 10,
turns out
11.
Like
like carrot
carrot are
refuse to eat
confirmed.
them.
These two,
Oh,
9,
right.
7,
they don't like it and they're not eating it. Should be this.
9, 9 over 30.
Let me confirm these answers first. This is
Can we
2A,
can
2B,
simplify the 9 and 30
14, 7, and
to
9.
get
Yes.
yes, sir.
What type of person does the number 4 in the diagram represent?
Uh, the for the children who like it, but they don't eat them.
Yes. Question number 3. A group of 50 students have the option of going on two different school trips. Total 50, two different school trips. 20 of them are going to museum. Let's just make it museum. 20 total are museum and to the theme park. 20 of them are going to the museum and to the theme park. 18 of them are going to museum but not the park. Museum and theme park. 18 of them are going to museum but not the theme park. So I think this should be the data. 20 is museum and 18 are
Yes,
museum but not theme park. And it says 3 are not going on either, 3 stays outside. And there were total 50. So if I would just subtract 18, 2 and 3 from 50, 50 minus 18 minus 2 minus 3, I'm left with 27. So remaining 27 should be going to theme park if everyone is joining. So illustrate this information Venn diagram where the set M represents the student going to museum and set T represents student going to theme park. If student is randomly selected, find M complement intersection T. M complement is other than M, which is 27 and 3, and intersection part is only 27. 27 by 50. Universal was 50. Then it belongs to M is clearly 20 by 50. T alone is 27, 28, 29, 29 by 50. And first was M complement intersection T. This time it is M complement union T. So M complement is only 27 and 3. And we make it union with T is another 2. So 27 and 3, 30, 32. 32 by 50. Question 3. No. Why am I having 27 and he's having 9? 20 in both. Oh my god, oh my god. 20 of them are going to museum and to theme park. That was clearly given. And 18 only museum. This should stay 27. M only is 20, 30, 38. And T is 20, 20, 47. And M complement union T. M complement union T is 50. Oh, and I need to adjust this as well before solving. If that's 20, total is 50, 20, 18 in this, 30, 30 minus 3 is 27, 9. M complement intersection T, M is not there. The intersection T is only 9 by 50. M is 20, 30, 38 by 50. Probability of T is 29 by 50. And M complement 93 union with T. The 20, 29, 29 and 3 is 32 by 50. I just hope this is correct now. That's question 3, 9, 38, 29, 32. 9, 38, 29, 32. Any confusion?
No,
No, sir.
sir.
Try question number 4.
Sir, the ones that have been to uh, Italy and Spain is 4 by 12.
Italy and Spain is, sorry,
4 by 12.
4 by 12.
And headwind to Italy is 8 by 12.
8 by 12.
And headwind to Italy is 4 by 12.
4 by 12. Let's see. Question 4B. 4, 8, and 4. Correct. Are this okay?
Yes, sir.
Okay. Question number 5. A book has 30 members. A book club has 30 members. Some of them like detective stories, some like historical fiction, and some like science fiction. And one member does not like any of these genres. This information is illustrated in the Venn diagram. If a member of the group is randomly selected, find the probability that they like detectives. So total, be with me this time if I make no calculation error. This is 5, 6, 7, and 14, 15, 16, 17. These are 17 out of 30. Now, probability, the intersection of H and S. This is H, this is S, intersection is 5 and 2. That is 7 by total. Then it says probability of S intersection D complement. So D complement is everything outside D, and the common part with this is these two, 6 and 2. So that's 8 by 30. H complement is anything outside H. So outside H is 2 plus 7, 9. 9 plus 6 is 15. 15 plus 1 is 16. 16 by 30. Last one says intersection of all three, DH and S, which is clearly 5 by 30. Question number 5. 17, 7, 8, 16, 5. 17, 7, 8, 16, 5.
Yes.
Try question 6. And Haris, I need your participation.
Yes, sir. Sir, X is 2. X is 2. 12. X is 12.
X 12. Ali, what are you getting?
1 second, sir. Yes, sir, I got 12. Exceeded 12.
Okay. So if that's 12, I'll just like to fill in some values. 2 into 12 is 24 plus 1, 25. 12 plus 1 is 13. This is 12. 12 minus 4 is 8. 8 2 times 16. Okay, B part. How many? Find the probability that randomly selected students studies biology.
Uh, 66 over 120.
27, 17, 10, 12,
66.
66 over 120. Chemistry and physics.
Uh, 25 over 120.
25 by 120. Chemistry, but not biology.
Uh, it's 38 or 120.
Very good. 38 by 120. Does not study physics.
Uh, so about 68 over. I'm sorry, 69 over 20.
69 by 120. Aris, please confirm. Are we getting same answers?
Yes, yes, sir.
All of them?
Yes, yes, sir.
Okay. Seventh. Positive whole numbers from 1 to 20. F, P, and T are set of positive whole numbers such that F is 1, 2, 3, 4 is missing, 5, 6, 7 is missing, 8, and so on. Missing numbers are increasing. So let's leave that behind. P is this and T is this. Illustrate these three sets in one diagram. Okay. F, P, and T. This is F, this is P, this is T. So before writing, we'll need to look at them closely if they appear in 1, 2, or more. So 1 is only in F. 2 is in F and P. 3 is in all three of them. 4 is in none. 5 is in F and P. F and P. 5. 6 only T. 7 is in only P. 8 only F. 9 only T. 10 is missing. 11 only P. 12 only T. 13 is in F and P. 14 missing. 15 in T only. 16 missing. 17 in P only. 18 in T only. And 19 in P only. We have two blank spaces. I think I should check this first and then move on to A and B parts. This is question 7. Okay, yeah, we have two blank spaces. This is 1, 8, 2, 5, 13. 1, 8, 2, 5, 13, and then 7, 11, 17, 19, 7, 11, 17, 19, yes, then a blank space, and 6, 9, 12, 15, 18, 6, 9, 12, 15, 18, and 4, 10, 14, 16, 4, 10, 14, 16, 20 as well. Why did I miss 20? The universal is still 20. Okay. Now calculate the probability of F intersection P. F intersection P. Try this first one. I'll do the letter with you.
Sir, one is forward 20.
Very nice. So these were elements. I was just waiting if you would just count them or add them. So that is correct. 4 out of 20. F union T. Complete F circle.
And
Complete T.
so, I think 11 over 20.
Very good. T intersection T complement.
This will be the intersection.
Mhm.
7 over
Very good.
20.
7 by 20. F Complement, union, P complement.
Unity complement. Hmm.
Let me highlight. If we are talking about F complement,
This is 16.
this is there. Yeah, maybe. And if we are talking about P complement, we are talking about all these. And then we are doing union of this. So this
Yes.
these four are left out, and yes, 16 out of 20.
20. 5.
P union T complement.
F.
F union T complement.
F unity complement. F is F. Yeah. F unity. Yeah, so it will be 15 or 20.
Correct.
Yes, sir, 15 over 20.
4, 11, 7, 16. 4, 11, 7, 16, and 15. And 15, yeah. Okay, conditional probability is definitely as the word explains. There is some condition, something is already given that should happen in that order. So, for example, if I would just draw a simple tree diagram that there is a black ball and white ball, and then again there are two outcomes, black and white, black and white, and then black and white. So, listen my words carefully. If I say what is the probability that you get a white ball followed by a black ball, white followed by black, is this chain only that you first get white and then you get black. So the condition was given. You're getting white followed by black. So, and this is the formula how you write it. This is probability of A given B. That means he's asking about the probability of event A to occur, and it is given that event B has already taken place. And how do we write it? A given B means probability of A intersection B divided by probability of B. Whatever will be in the second place will be in the denominator. Numerator is intersection, that is AND part, and denominator is the second one, the given one, which has already happened. So, example, the first one says probability of B intersection C. So that is, sorry, B given C is probability of B intersection C divided by probability of C. So if we look at this, intersection part is 12 out of how much? The total is 50, and divided by probability of C only, that is 20 divided by 50. Cancels out, that is 12 by 20. Would be simplified more. And then C given B, again numerator is intersection part, B intersection C, which would stay same, 12 by 50, and probability of this is 25 plus 12 is 37. So 37 by 50, 50 cancels out, 12 by 37. Okay. A regular pack of playing cards contains 26 red cards and 26 black cards. If you are asked to pick a card at random, what is the probability that you choose a red card given that one black card has already been removed from the pack and not replaced? Okay, I find these card questions hard. If you are asked to pick a card at random, what is the probability that you will choose a red card given that one black card has already been removed? So probability of red given black. This should be a red intersection black over probability of black. Okay. 26 red cards. Somehow I just have a feeling that tree diagram would help more. That if this is the order, that black has already occurred, and then there's red. So probability of selecting this black would be actually 26 by 52, and then it is not replaced, and then we are left with the red, that is 26 over 51. 26 by 52 into 26 by 51 is giving me 13 by 51. Let me check that answer. This is 14.61. 26 by 51. Why am I getting 13 by 51? 26 by 52. Why am I getting half of that? A regular pack of playing cards contain 26 red cards and 26 black cards. If you are asked to pick a card at random, what is the probability that you will choose a red card? How self-explanatory. That makes sense actually. See, I'm picking up a red card. How many red cards are there? 26. Out of how many? Black has already been taken out, so the total remains 51. This is 26 by 51. Does that make sense? You're making a pick of red card, and given that black has already been taken, so the total is reduced. There was a deck of 52. One black has already been taken out, and we are left with 51 total. Out of these, there were 26 red, so 26 by 51. Let's try question number 2. Tyre collected the Ty. Ty collected the following seashells one day: 3 Scotch bonnet and 4 lightning wicks and 2 calico claims. She chose one at random and gave it to Erica. She then chose another one at random for herself. What is the probability that Ty shell was lightning wick given that? Okay, so she's selecting lightning and she gave Siliso to Erica. So there, these were 3, 4, and 2. 3, 4, and 2. Total is 3, 4, 5, 6, 7, 8, 9. Total is 9. So this time it should be, if she's selecting lightning, these are 4 out of, this should be 8, because she's already given one Siliso and the total remains 8. 1 by 2. Let me check that at this stage. 2A1. 2A1, 4 by 8. Correct. Second part says Scotch. So still she's selecting lightning and 1 is reduced, and that was not lightning, so still it is 1 by 2, 4 by 8. What is the probability that they both had lightning? Hmm. So both had lightning is 4 by 9 into 3 by 8. So if the first one is having lightning, the probability was 4 out of 9, and then we select again lightning is 3 out of 8, 12 out of 72. Any confusion in both of these? 2A.
No, sir.
Okay. Try question number 3.
Okay, sir. So A is 24 by 50. 24 by 50.
24 by 50. Let me check. This is 3A correct. 24 by 50.
Yes, sir.
B pi.
And gelato is 23 by 50. And and B is 23 by 50 and C is 17 by 26.
Sorry, I missed your voice. 23 by
50.
and C was
C is 17 by 26. 17 by 26. And D is 14 by 23.
14
14
by
by 23.
23. Okay. Let's check
And
these. B 23 by 50, 17 by 26, and 14 by 23. Very nice. Aris, you getting same answers? Or you want to discuss something?
Then I'm getting same.
Okay. Gelato, given that they chose chicken curry. Last part.
this is 14 by 24.
14 by 24. Correct. Let's try this tree diagram. If Kebo is late for school, the probability that Leland is late for school is 0.7. Late. Okay, if she's late, probability for that she's late is 0.7. And then if Kebo is not late for school, there is a probability, there is still a probability of zero point 0.2 that Leland will be late. If she's not late, still 0.2. So this complete should be 1. If that's zero point 0.2, not late is 0.8. On the other hand, this is 0.3 and zero point 0.2, this is 0.8. Tree diagram done. Here is a tree diagram illustrating the information. Copy and complete the tree diagram. Done. What is the probability that Leland will not be late given that Kebo is late? So Kebo is already late and she will not be late. So this should be 0.3 for B or B. Where's for B? Oh yeah, 0.3. For B is 0.3. So this is 0.3. Then what is the probability that Leland will be late for school? So okay. Now this time will be late this and this option is there. That no matter what happens, but she'll be late. So this end result should be 0.7 into 0.2, 0.14, and this should be 0.16. 0.14 plus 0.16 is 0.3 again, is 0.3. Any confusion?
No, sir.
Okay. We've done these type of questions. Okay, let's just try this and then syllabus would be complete and we move on to past papers. Let A and B be two events such that probability of A is given 0.8. And you can see the split. Probability of B is given 0.7 and intersection part is zero point 0.5. The Venn diagram illustrates these probabilities. Find probability A given B. The formula was numerator will be A intersection B divided by B. So if we look at the intersection part, that is 0.5 divided by probability of B is 0.7. So this is 5 by 7. Does that make sense? 7A
Yes, sir.
is 5 by 7. Try 7B.
Okay.
Done? B part.
So 5 by 8.
5 by 8. Haris, B given A is intersection zero point 0.5 divided by
Yes, sir.
A, that is zero point 0.8. So 0.5 by zero point 0.8 is 5
5
by
by
8.
8. Yeah.
Haris, try C part.
C part.
Yeah.
Okay.
A intersection B complement.
Intersection B complement. I think it's 1.
First, the numerator. Which part is A intersection B complement?
Intersection B complement is 0.3.
Very good. And what is B complement only?
0.5 plus. No. What is it?
That is 0.3, Haris.
Oh, yeah, 0.3. Yeah, 0.3.
This should be 1. C part is 1. Last part. B
B.
complement is this.
Yes.
A complement is this. And there's
Mm-hmm.
no intersection in them. This should be B complement intersection A complement divided by A complement. And probability. Numerator is already 0, so we just leave it there.
So it will be 0.